Yes, hi. Good afternoon, everyone, and welcome back to the channel. I was asked to do a quick flyover blood gases and balancing and maintaining acid base and so on and so forth. So let's go ahead and take a quick look at this. Now, then again, as a form of disclaimer, I am going to say that this is not even acid balance 101. This is acid balance 0.0001, just to kind of remind you of some of the very main concepts and to bring forward some of these patterns that I want you to see to make discerning these issues a bit easier. Okay, let's just begin by saying that the normal plasma pH is 7.35 to 7.45. And what is pH? Well, pH is the concentration of hydrogen in any given compound, right? So the more hydrogen that you have in a compound, the more acidic it's going to be. And conversely, the least amount is going to be a more basic substance. In other words, pH in real life is a scale that goes from 1 to 14, with 7 being right spanking in the middle, right? Anything in between 1 and 7 is acid. Anything between 7 and 14 is basic. In other words, 7.1 is already basic, 6.9 is already acid, right? But then again, that is real life, and that is for chemical compounds other than humans, other systems, right? In our system, within our body, for humans, 7.35 to 7.45 is normal. Even though in the real scale, it will be a little basic, that is okay for us, okay? 7.35 to 7.45. That is our normal pH value or range, okay? Now, within our system, we're going to have a major buffer system, the bicarbonate carbonic acid buffer system, right? And a buffer, think of a buffer as a guy that gets in the middle of a fight and breaks up the fight, right? Whenever somebody gets mad and somebody else gets mad, they fight. This buffer system is the one that gets in the middle, breaks up the fight, and tells you who created the fight and who reacted to it and so on and so forth. Now, some of the concepts that I want you to equate, marry to each other, etc., right? I want you to always remember that kidneys are bicarbonate, and this is related to the word metabolic. Okay, so kidneys, bicarbonate, and metabolic all mean the same for the purposes of this video, right? Whereas lungs, carbonic acid, and the word respiratory mean all the same and are the other part of the buffer system, okay? So this buffer system that splits into bicarbonate and carbonic acids, right? The bicarbonate has to do with the kidneys, bicarbonate and metabolic, whereas the carbonic acid is going to be right here with the lungs and is going to be on the respiratory. And with just remembering that, that's all I need for now for you to remember. And for the purposes of this video, we're not going to enter into other buffer systems. Let's just leave it like that. Okay, now, number one, metabolic acidosis. The moment that we hear the word metabolic, we're going to think of kidney and bicarbonate. Okay, immediately. That's the first thing that we're going to remember. So this is something metabolic. It's got something to do with the kidneys, and it's got something to do with bicarbonate. Now, in the case of metabolic processes, what I want you to remember is that they always march out, right? When I am going to look at the pH is going to be low, and then I'm going to take a look at the bicarbonate, and that bicarbonate is going to be low. They will march out for the most part, Okay. So in the case of metabolic acidosis, is most commonly due to a kidney injury. Who would have guessed, right? Kidney goes directly with metabolic and directly with bicarbonate. See it? So I want you to marry the word metabolic with kidney and bicarbonate. With that being said, this is commonly due to a kidney injury. You're going to have certain manifestations in here, confusion, drowsiness, so on and so forth, right? And how we solve this problem? Well, we correct the underlying problem, right? If this kidney injury is acute, we correct the problem, whether it's pre, intra, or post-renal, and then we'll go from there, right? In the case of acidosis that is metabolic, hyperkalemia occur as potassium shifts out of the cell, right? And out of the cell into the bloodstream, and that causes the hyperkalemia. Then again, let's go ahead and remember that within the cell, we have potassium living there, and outside we have sodium, right? Potassium is the guy that lives inside the cell primarily, couch potato, and this is the guy that on the weekends go out hiking and mountain biking and all that. Very active guy, very lazy guy, right? He lives inside, couch potato. Okay, so when that couch potato gets out of the house, then you have hyperkalemia in your serum, right? As acidosis is corrected, then this potassium shifts back into the cell and the potassium level will decrease, right? We have to monitor potassium levels and serum calcium level, so on and so forth. The important thing here to remember is that, then again, really basic, guys. We're going to keep it really, really basic. Metabolic, you have to marry with bicarbonate, and you have to marry to kidney. And the other thing is that in a metabolic process, pH and bicarb will march out. In the case of acidosis, you know, number one, that in your pH scale, the lower you go, the more acid, and the higher you go, the more basic you're going to be. Therefore, if they're telling you here that it is an acidosis, you know your pH is going to be low. But you also know that in metabolic processes, this pH and this bicarb will march out, will go up together and down together. Therefore, if my pH is low, I expect my bicarb to be low. And in fact, if you take a look at the slide, you're going to see that the pH is in fact, I'm sorry, the bicarb is in fact low. Okay, so moving on, let's go ahead and take a look at the contrary of this. Metabolic alkalosis, right? The fact that they're telling me that it is an alkalosis, also known as basic and alkalosis is the same thing, right? That is telling me that the pH is going to be on the high end. And then again, if we take a look, sure enough, it is on the high end. Now, metabolic talks about kidney and talks about bicarbonate. So it's given by the bicarb, and because it's a metabolic process and in metabolics, everything marches out, then more than likely that bicarb is going to be high. Okay, they march out. So pH and bicarb, and we're looking at bicarb because they're telling me it's metabolic, right? So if I have a high bicarb and a high pH, then, you know, high pH is going to be alkalosis, and high bicarb is going with the high pH, then this is a metabolic process. Simple as that. Let's keep it really, really, really simple. Manifestations and treatments and so on and so forth. You have it. It's up to you guys to read it. All right. So let's go ahead and move on. And now we're going to get out of metabolic and we're going to go into respiratory. And remember when we said at the beginning, respiratory, right? It's going to be lungs and it's going to be carbonic acid, right? All right. So respiratory, okay, it's going to be a respiratory problem. It's going to be lungs, right? And well, this is not carbonic acid, but let's just call it carbonic acid, right? PaCO2 is what we're going to measure here, okay, which is different from bicarb. Now, if they are telling me that it is an acidosis, then I know that my pH is going to be low, because remember, acid is towards the lower end whereas basic or alkalosis is towards the higher end, right? So if they're telling me acidosis, I know automatically that my pH is going to be low. Okay. However, because it is respiratory, I'm not going to take a look at the bicarb. I'm going to go ahead and take a look at the PaCO2. And this PaCO2, check this out, is going to be high. Okay, greater than 42. And then again, keep in mind that different textbooks will give you different values, right? And sometimes textbooks are going to tell you that that ABG, the PaCO2 goes all the way to 45. So anything above 42, they're considering high, and this is a respiratory lung-related acidosis because it is pH that is low. Okay, the next thing that I want you to notice that in respiratory, as opposed to metabolic, these values do not march out. When the pH goes low, the PaCO2 is going to go high. They're going to go in different directions, right? Metabolic marches out, respiratory does not. It's directly, inversely proportional. They march out differently in different directions. Okay, but we know that this is a respiratory acidosis because number one, they're telling me it's acidosis and the pH therefore is going to be low. If the pH is low, I am going to assume that if the problem is respiratory, then the PaCO2 is going to be high because they don't march out together. They go in different directions. Okay, and the same thing applies to a respiratory alkalosis. Okay, the only difference in here is that alkalosis means that your pH is going to be high. And therefore, if it is respiratory, you can assume that PaCO2 is going to be low. In other words, I want you to look at the green now. I'm going to highlight in green how this one is high and this one is low. Okay, or they go in different directions. With that being said, let me go ahead then and do a couple of problems, right? Number one, let's go ahead and have a pH. Sorry, guys, let me go ahead and put it in red. We're going to have a pH of 7.33. We are going to have a bicarb that is going to be 21. And how would you call this? Well, let's begin from the beginning. Is this pH low? Then it is acidosis, right? And let's just remember that we always come up with the last name and then we take a look at the first name. Okay. If the bicarb is low and the pH is low and the two of them march out in metabolic processes, then more than likely this is a metabolic acidosis, right? And this is the basic of reading these problems, right? Let's go ahead and complicate this a little bit more. Number one, we're going to have a pH of 7.33. Let's make this 7.33, right? Let's go ahead and have a bicarb of 21. And then let's have a PaCO2 of 40. Okay, now, then again, one step at a time and always the same process. Always stick to your guns, stick to the same process. Number one, last name. Last name is about pH. pH is going to tell you the last name. Is this pH low or high? Well, this is a pH that is low, right? Because the normal pH goes from 735 to 745. Therefore, this is low. And if it is low, we call that acidosis. Okay, so now step number two, let's go ahead and find out which one is the buffer system that's causing the problem. Is it the kidney, is it the lungs, is it the bicarb, or the PaCO2, okay, or carbonic acid? Let's go ahead and now take a look at these two guys. And whomever is going to be out of range here, that's going to be the problematic guy. PaCO2 of 40 is a normal value. However, a bicarb of 21 is not, right? Slightly decreased. Therefore, the problem is coming from the bicarb. And we know that bicarb is the same thing as saying kidney, or the same thing as saying metabolic. And therefore, this is a metabolic acidosis. Okay. All right, let's take a look at another example. Let's just say that we have a pH. Well, that doesn't look like a pH, does it? We have a pH of 7.46. We have a bicarb of 27, and we have a PaCO2 that's equal to 39. Well, then again, just like we said, let's go ahead and stick to the process, right? Same steps every single time. First, we find out the last name. Who gives us the last name? The pH. So let's go ahead and ask the pH. Hey, Mr. pH, are you high or are you low? Well, this pH is high. Therefore, this is not an acidosis, this is an alkalosis. Okay? This compound is basic, alkalosis. And then we go to the first name. But who gives us the first name? Well, the first name is given by analyzing these two guys. And whomever is out of range is going to be the problem guy. Now, PaCO2 of 39, this is a normal value. However, 27 is a little high. Okay, 27 is a little high for the bicarb. And bicarb is high. And pH is high. They're marching out together. More than likely, this is a metabolic process. And more than likely it's not. It is a metabolic process because at the same time, remember, the one that is causing the problem is the bicarb, or the same thing, kidneys, or the same thing, metabolic. All of them mean the same thing for you. So metabolic alkalosis. Now, moving on, let's take a look at another one. Let's say that we have a pH of, let's call this pH a 7.34. Let's call it a 7.34. And then we're going to have a bicarb. And we're going to call this bicarb 25. And then we're going to say that PaCO2 is going to be equal to 46. Okay, now, then again, let's go ahead and stick to the same process. Last name, and that last name is given to us by the pH. Let's ask Mr. pH, are you high or are you low? Well, 7.34 is low. So this is going to be an acidosis. However, what type of acidosis? Where is it coming from? That is the question for our first name. And the first name is going to be given to us by the differences between these two guys. Okay? Now, PaCO2 of 46 is slightly high. And a bicarb of 25 is normal. Therefore, right, we have a high PaCO2 and a low pH. And remember how in respiratory things do not march out. They go in different directions, and this one is going high. I'm sorry, backwards. My bad. This one here is low, and this one here is high. They go in different directions. So more than likely, this is respiratory. But then again, how do we know for sure? Well, let's see. In here, the PaCO2 is the one causing the problem. Therefore, this is equal to respiratory, right? Equals to lungs, and so on and so forth. Therefore, this is a respiratory acidosis, right? And last but not least, let's go ahead and take a look at another one. This is a pH of 7.46. we're gonna have a bicarb that is going to be, let's call it 24. And then we're gonna have a PaCO2, and this PaCO2, we're going to call it 33. All right. Then again, stick to your guns, follow the process. Number one, what's the last name? Last name is going to be given to us by a pH. All right, Mr. pH, are you high or are you low? Right, this pH is high, so we're going to call it alkalosis. Last name, alkalosis. Now, first name is going to be given by the differences between these two guys. All right, so, well, number one, let's go ahead and ask the PaCO2. Are you high or are you low? This PaCO2 is low. However, this bicarb is normal. So the problem here is coming from the PaCO2. This equals lungs, and this equals respiratory. So therefore, the name here is of respiratory alkalosis. And if you take a look, this pH here is high, and this PaCO2 is low. Therefore, when they don't march out, they go in different directions. We call this a respiratory. This is a respiratory problem, okay? So with that being said, that is it for this ABG acid-base balance explanation 0.0001. Questions, concerns, please let me know. Thank you very much for being here today. If you like it, give it a like, share it, let everyone know, and see you in the next round. All right.